Welcome, everybody. In the latest years, we are facing some new challenges in the HMI design. OEM are challenging time to market. There are new technologies rising. The automotive industry is evolving very quickly, and demand of user experience as a differentiator is rising among the latest years. Traditional design are limiting on over time, technology budget. That's why there is this need of having a balancing between user friendliness with safety and comfort standards, where it's difficult to test in early stages new technologies and also lead the design of interiors for user experience and ergonomics. That's why there is the need for advanced solutions to help OEMs go through this different difficult process. Some trends on the industry. There are new components and features in the vehicles that are rising in the last years, such as interactive voice assistance, most of the cases also supported by AI technologies. Multiple displays integration with different sizes, and also central computers, where the infotainment ECUs are becoming more and more complex. There are also pop-up displays, disappearing displays, in-car streaming services, 5G connectivity that also allows the connection between a vehicle to vehicle and communication also vehicle to X. The also cameras inside the vehicle, driver monitoring cameras as well. New features to assist the driver and the passenger for ADAS. And also the new applications of app-based control systems. Not only major stream vehicles, passenger vehicles, but also ultra powerful vehicles are facing the same challenges in HMIs. For example, here I report a quote of a customer of ours from automotive Lamborghini, where they say they need to find the right balance for between immersiveness, the performances, still having the passenger at the central, the driver as the center of the experience, and for which also driving simulators could be a very helpful device and tool for developing HMIs. For that, we launched the new HMI, compact HMI simulator.
As the automotive industry undergoes rapid technological transformations, the human-machine interface plays a pivotal role in shaping the driving experience. Yet designing intuitive and effective HMIs remains a significant challenge. Traditional design methods are often slow, costly, and rigid, making it difficult to keep up with the rapidly changing automotive industry. Engineers and designers must balance the challenges of ensuring user-friendliness for both the driver and passengers while maintaining strict safety and comfort standards. Introducing the revolutionary Compact HMI Simulator by VI-Grade, a game-changer in automotive HMI design and testing. Our compact HMI simulator features adaptable seats, steering column, and pedals, allowing it to replicate nearly any automotive configuration with unmatched flexibility. With just a single touch, the internal setup of the compact HMI simulator transforms to any user-configured arrangement, reliably replicating the ergonomics of various interiors. It features several dashboard screens, ensuring comprehensive testing and a fully immersive experience for both driver and passengers. Active steering torque feedback and high-quality audio via VI SimSound further enhance the immersive experience. Ultra-realistic driving environments can be enjoyed with VI WorldSim, displayed in stunning detail on an 86-inch LCD screen. Leveraging the virtual and mixed reality technology enabled by Vario XR4 headsets, the HMI simulator can also be used with no screen, allowing for instant swapping of virtual cockpits and revolutionizing the way HMI designs can be tested and refined. Step into the future of automotive design with the VI-grade HMI simulator, offering an unprecedented level of immersivity and flexibility in the market. VI-grade compact HMI simulator, redefining the driving experience one interaction at a time.
So the compact HMI simulator can be used as a key device during the whole development process for the HMI and ergonomics at OEMs and the tier ones. Can be used for different stages of the development process. For example, to collect subjective feedbacks and driver perception, to conduct also clinic tests with random drivers and customers, to assess ergonomics, driver interactions between not only HMIs but also the interiors, the reactions of the driver and awareness, also integrating driving monitoring cameras, the behavior through also cameras that allows to track the movements of the driver and the passenger, and also to check and test the other sendover moments while the car is in a level 2 or level 3 driving mode. It also helps customer to develop new features in the HMIs, to test the graphics of the HMIs, to test the usability, to implement also the coding for the HMI ECUs, to training the driver, and so on and so forth, to validate virtually the whole tool chain. Which are the key components of the compact HMI simulator? First of all, a flexible simulator frame that is a modular with automatic adjustments for the seats, for the steering wheel, the pedals. Also the frame itself can be positioned at a different height to emulate the ingress, egress of any sort of vehicle, from very low sports car, super sports car to SUV vehicle. The driving hardware, we are still talking about a driving simulator, so there is the need of having all the hardware required for a proper driving simulator, such as the steering wheel, pedals, the seat, and as optional also active systems like active seat belts, visualization tool. The standard product comes with a flat screen, a large flat screen, but can be also equipped with a projection system. And also it's ready for having mixed reality device, Vario XR4, fully integrated in driving simulator. As a HMI monitors, we have the system comes with the 3 different size of multi-purpose touch screens for cluster, central display, and passenger, but is also equipped with all the I/O boards for having the proper protocol, automotive protocol, for then integrating ECUs, HMI ECUs, in infotainment ECUs later on with communication through CAN, CAN-FD, LIN or FlexRay, and automotive Ethernet. Driving monitoring is also a feature that can be installed on the driving simulator. And of course, last but not least, it contains the tool chain for the simulation. So the real-time system, a vehicle model, a real-time vehicle model, and the visualization environment via word sim, the graphic, of course, hardware, the sound and vibration, and the connectivity. Some deep dive into the flexibility of the cockpit itself. The frame is totally modular. It's able to mount and unmount the physical parts, such as rapid proto parts, door panels, roof, A-pillar, interior dashboards, and full panels with the rapid proto or veneer parts. And as you can see, there is a full adjustability of all the components in automatic mode or manual mode through a dedicated interface. Huge operation of adjustability, easy to plug and play different displays and swap with different size, and also interact on the real-time simulation. Key features, as I said before, the seats, the steering column and pedal are adjustable in automatic way. There is a configuration through touchscreen, dedicated touchscreen, where with a single touch, the customer can set up, insert a new set of vehicle to be driven, and the simulator will start to fix the positions in the proper position, reference position, and then the user can then modify manually the every single adjustment. It can replicate nearly any automotive configuration, from a very low vehicle to very high vehicles, such as SUVs. The one-touch transformation, it's really a plus, because it's in a matter of seconds, the driving simulators can reach the exact sitting position as a vehicle design at OEMs, and then create the references and then adjust the different position according the feedback from the driver, and save those positions and then store the data in a dedicated repository. The reliability of the system, it's guaranteed through a dedicated PLC, where linear motors are used in the driving simulator to guarantee also maximum precision of the different positions. The multiple dashboard screens with the off-the-shelf components allows the possibility to have a rapid proto design of the HMI interface, and later on also implement those graphics into automotive graded screens. The active steering top feedback also gives the right impression, immersivity during the driving experience, as well also the high quality is guaranteed through VI Sim Sound. The same system, as said before, is ready to host mixed reality capabilities, where the customer can also upload the full interior graphics. Here in the next slides will show how to do it. What is important that it's in any moment we can swap from mixed reality to virtual reality to a normal driving conditions with the monitor in front of the compact HMI simulator. The flexibility is guaranteed through for both the passenger and driver. There is also the possibility to add, the system is flexible and have the possibility to add a second row of seats for the rear seat passengers, as well also having the possibility to add extra components such as push buttons, scrolls, and also physical components coming from previous models or rapid proto parts. The design of the simulator is a mix, allows a mix of virtual and physical technologies, In any case, this represents a good platform for HMI design. The market advantages immersivity, the level of immersivity and precision in terms of ergonomics, positions, and HMI design is unprecedented, is unparalleled compared to all previous driving simulators offered by VA grade. And it represents really, it positions the user at the forefront of automotive design. In terms of mechanics, underneath the seats and every components ensure a proper and precise location of the components. The podium is surrounding the driving simulator is there to guarantee the zero reference of the ground. And the back of the driving simulator hosts the PLC control entirely developed by VA grade. Here's some detail of every single components and the movements that can be adjustable in every direction. A steering wheel with also the possibility to change the tilting of the steering wheel. The front side of the cockpit with the possibility to host a different height of the cluster display. Pedals can be fully adjustable. Seats are not only adjustable in every direction, but also with the possibility to, through a quick release adapter plate, easily swap seats with a manual adjustment or electric adjustment seats. We also foreseen an extra power connector and network connector to easily and fast add extra components on the central tunnel or on the central display. The center console also can be easily adjustable manually, same as the passenger display. The interface to control everything is designed by VA grade, and every single movement can be modified manually, or 3D drawings from CAD can be imported, and a specific vehicle can be reproduced in terms of ergonomics on the Compact HMI simulator. So, in few words, the Compact HMI enlarged the already existing family, broad family of a driving simulator of VA grade. Just to remind that we have desktop simulators, compact for air handling, compact for MVH, compact FSS, static, and then small and large dynamic simulators. The HMI simulators add another layer for a different type of target customers that are not MVH engineers or vehicle dynamics engineers, but they are HMI and ergonomics engineers. They need total flexibility to test very different vehicles and test a very different type of technologies on the driving simulator, still keeping inheriting from other departments, vehicle models and other scenarios, and test it on this new Compact HMI simulator. Now, I would like to hand over to my colleague Iain to have a deep dive into VR sim and mixed reality technology.
Great. Thanks, Alessandro. So, as Alessandro said, this is a full-blown driving simulator, and I'm going to touch on some of the software components that we develop to not only interact with the HMI displays and the driver, but also simulate the world in front of the driver so they have scenarios and environments in which they want to drive in. One of the key components of that is our VI World Sim. So World Sim is our high-quality graphics engine. It's based off of Unreal 5.1. It is very intuitive and easy to use. You can author up a scenario very quickly, and a scenario being a layout of vehicles in a world with a set of events that are going to happen. And one of the beauties of our WorldSim technology is once you've authored it on your desktop, you can then promote it to any of our simulators without modifying it, and it works on our HMI Compact, our Compact FSS, our large dynamic simulators, and even in VR, you don't have to alter the world one piece. We have an AI traffic engine and ability to control pedestrians and animals, and they can have a life of their own within the environment. We can also simulate sensors in the environment, very popular for people developing ADAS algorithms. We have camera sensors, LiDAR, radar, and ultrasonics, and that can be integrated into your HMI, because ultimately the output from the ADAS will be represented in the HMI display that either gets turned on or off or provides some form of haptic feedback to the driver. So we can simulate those sensors within WorldSim. Allows you to use the driving simulator for very realistic subjective feedback, because once you're immersed in that world, people think they are driving a real vehicle. We have the ability to author, like I said, author many scenarios, and we also have some pre-configured scenarios delivered with the WorldSim product, and it's fully integrated with our DriveSim technology for controlling the simulation. WorldSim has many different visual levels. We have a comprehensive proving ground that we deliver with our core WorldSim product. It provides road surfaces for ride and handling, high-speed circuit, highway simulation, country road simulation. We also have some GPS-accurate worlds within the digital twin space. We have all of, about 13 miles of downtown Chicago mapped out, Wolfsburg, racetracks. There's about 250 different tracks and environments that are currently available. And we also have the ability to develop or import your own world tracks into WorldSim if needed. When we actually develop the worlds, we make sure that they're highly accurate, right down to tree placement. Here's an example of a WorldSim graphic output versus a Google Maps using the Street View capability. And as you can see, down to road signs, tree placement, the only thing that doesn't update is the gas prices at the gas station. But we try to get as realistic as possible, and this gives you an idea of the quality of the renderings that we can get out of WorldSim. One of the things that you probably want to do within the HMI simulator is actually bring in your own visuals of your car interior. And we offer a mod kit capability within WorldSim where you can actually import a 3D model, exterior and interior, and then drive it within the simulator. And we have a 3-stage process for bringing that into the simulation. First of all, you start off with your 3D model, usually in an FBX format. We categorize the meshes into groups, or logical groups: interior, exterior, steering wheel, front wheels, rear wheels. And then we have a import mod kit capability that will bring in that mesh and adapt it and alter it so it becomes Unreal capable and WorldSim drivable within our simulation software. And then you basically import that asset into your WorldSim session. You deploy the vehicle, place the vehicle on the road, and you can drive it. This can give you the ability to bring in your own custom vehicles into WorldSim. Although we do offer, 100+ vehicles within the WorldSim environment, most of our customers want to have their own graphics within the simulation. WorldSim also offers a VR AR capability. And this is for total immersion. So, WorldSim can run on a flat screen in front of the simulator. It can offer a multi-projection wraparound screen, or a full 360 immersion within VR XR. Here's a quick video I'm going to show. So within our VR simulation, it's all based on the Unreal 5 engine, like I said. And here's an example of a detailed interior that we brought in within the VR space. You have the ability to do a AR pass-through. So we can actually, if you noticed in the video, we had green screen capabilities with the real HMI displays integrated into the green screen. And through our AR pass-through capabilities, we can actually pass the display into the virtual world. So I can see the driver can see their own hands, the real steering wheel, they can see the real dashboard, the real HMI display, interact with those displays, and still have the virtual world rendered around them. So this is all based off of the OpenXR standard. We have standardized on Vario as the headset we developed to. But because we support the OpenXR standard, we are compatible with other headsets. You may not get the best frame rates or the best resolution or the best camera AR pass-through with other headsets, but the Vario definitely meets the standard to give you full immersion. And it is fully supported within VI World Sim. If you author a world scenario event in a desktop capability, you can immediately deploy it onto a VR immersed simulation. We also have the ability to render the displays onto surfaces within the 3D models. You don't have to pass that through. We can do a heads-up display. We can do the center console. We just end up simulating active dashboards within the simulation. We also offer reflective, accurate mirrors. So as the driver's moving their head, the reflection within the mirror is reflected relative to their head position. So you get a very, very immersive 3D realistic view of your vehicle configuration. One of the last pieces of software I'm going to touch on is VI Dashboard. So within the HMI Compact, we have 3 displays, and on those displays, we can render user controls, vehicle dials, those types of things. And within VI Dashboard is one of our tools that we use for developing these displays. It's fully integrated within our DriveSim stack. We offer a fairly rich set of examples on how to hook those up to the simulation, so you actually get the data feeding the dashboard in real time. It is a direct connection to the real-time simulation. So as the vehicle RPM changes, the dial changes in the dashboard. As the user presses a button, that will give a signal back to the simulation to engage some feature. Fully interactive dashboard, so you can actually simulate your real HMI UI within the HMI Compact simulator. We have touchscreen compatibility, ability to integrate with the virtual world and the mixed reality capabilities, and runs on standard HMI displays and multiple aspect ratios. And we have standardized on Qt Automotive using the Qt Design Studio for doing the design layouts. But there are other tools out there, and we can actually integrate those tools into our simulation if needed. An example of some dashboards, racing dashboard giving a track layout, position on the track, some G meters, ability to turn off ABS and traction control, some track times. Again, all these data would be updated live within the simulation as it is running. We have a more traditional driver dashboard with some ADAS features, lane keep assist, automatic emergency brake, some feedback features from within the state of the vehicle, whether your high beam's on or not, that type of thing. And then we can also offer, like I said, a heads-up display. So if you're trying to do a heads-up display simulation to see how the user interacts with that, we can render that graphic onto a windshield. We can also offer a GPS output. So if there's an aspect of your software that has GPS needs, all of our worlds are GPS accurate. We can give a satellite signal out from that to drive your software, so you can actually do things like a nav system simulation within there as well. So thank you for your time this morning or this afternoon. And Alessandro are here to answer any of your questions.